Unit 3, Scatter Plots and Bivariates, Linear Regression, Predictions, Interpolation, and Extrapolation. Unit 3, Scatter Plots and Bivariates, Linear and Nonlinear Modeling. Objectives. The students will be able to create a scatter plot using technology to determine the appropriate regression model. The students will be able to determine the regression model that best fits the data. The students will be able to determine if the model best fit is linear or nonlinear. Linear and nonlinear scatter plots. Scatter plot, of course, is a graph of data points that shows the relationship between two variables or bivariate data. The scatter plot on the left is a linear scatter plot. The one in the middle is a quadratic scatter plot. And the third one is exponential scatter plot. Notice the differences in their shapes. Identifying regression models. Determine which sort of equation you think would best model the data in the following scatter plots and explain why. Choices are quadratic, exponential, and linear. So if you look at graph A, that looks like a straight line, relatively high correlation. Linear, these points appear to indicate a straight line. On the next one, example B, look at graph B and graph C because they kind of look similar. But graph B is quadratic. There appears to be a gentle increase as your x values increase. Whereas C is exponential, the points appear to hug the x-axis until about halfway, and then the y values increase quickly. Identifying regression models. Determine which sort of equation you think would best model the data in the following tables of values and explain why. Put the t's in list 1 and the m of t's in list 2 and create a scatter plot. This looks like a linear model. The dots appear to indicate a straight line. In the next situation, put your x's in list 1 and your t of x's in list 2. Create a scatter plot, and this looks quadratic. There appears to be a gentle increase as your x values increase. Put the t's in list 1 and the p of t's in list 2 and make a scatter plot. This looks like it's exponential. This time it's decay. The points appear to start higher on the left and appear to approach, get closer and closer to the x-axis as you go to the right. Quadratic regression. Graph the bivariate data below. Find the quadratic model that best describes the data. So they are telling us which type of regression we need to do. So in list 1, put your x's, and list 2, put your y's. We can make a scatter plot, and indeed it does look like quadratic regression. We are going to go stat over to calculate. This time we're doing option 5, quadratic regression, and this is what we get. The general form for quadratic regression or a quadratic equation is y equals ax squared plus bx plus c, and it gives us the values for a, b, and c. We can put that equation in our y1, and it does fit our data very well. The quadratic regression model that best fits this data is y hat equals 0.597x squared plus 0.05x minus 0.099. This time they're requesting to do exponential regression around to 3 decimal places if necessary. Our x's go in list 1 and our y's go in list 2. As I have shown here, we can do a scatter plot. It does look like exponential growth. We're going to go over to calculate. This time we're going to have to scroll down quite a bit to get to exponential regression. And you can see that option right there. We're going to put in list 1, comma list 2, as we always do. The general form is y equals a times b to the x. And it gives us the values for a and b to put in our equation. The exponential regression model that best fits this data is y hat equals 2.095 times 1.422 to the x power. Exponential regression again. The table at the right represents a population of Newtons since 1995. Write the exponential regression model, round to 3 decimal places if necessary. We need to put the years in list 1 and the population in our list 2. As you can see right here, we can do a scatter plot and it does look exponential. We need to go back to stat, over to calculate. We need to find our exponential regression. So you're going to have to go down a bit. Push enter and then list 1, comma list 2. This is what comes up for exponential regression. So the general form is y equals a times b to the x, and it gives us the values of a and b. The exponential regression model that best fits this data is y hat equals 246.924 times 1.499 to the x power. Now they want us to use this exponential regression model to approximate the population in 2003. And that would be represented by 8 years after 1995. So we write down our regression equation, and in place of x we put in 8. And the approximate population in 2003 would be 6,295 people. Assignment for today, there's a quizzes assignment, linear and nonlinear models for bivariate data, 5-point minor grade for completing, and you'll be able to check your answers. There's 2 Edpuzzle videos, one for quadratic regression and one for exponential regression, and they are 5 points each for watching them.